Thank you. I'm very pleased to be here, and I'm hoping to share something with you that was secret until the 90s. And here we go. I have a couple of icons here that I'll try and keep touch with during the presentation. One is Tubi, okay, the little tube that won World War II. And of course, the initial transistor. And then it got to be so good that it was electronic progress was made into a stamp, and you have to be important if they make a stamp about you. Okay, they also had one for Marconi and Edwin Armstrong, but so one thing about Camp Evans, there's so many heroes and there's so many good things. And before we started, I was running through two other presentations just to give an appreciation for how deep this place is. All right, who we are. We are a miracle. And part of the miracle is VCF. We're a bunch of organizations that got together, and as we look back further, we knew we did the impossible, but, you know, it's shocking. It's shocking and happy, and there's a whole bunch of heroes in it, people who rolled up their sleeves and absolutely made a difference. And for myself, it's a thrill to see so many people here at this gathering to do things that they love and have passions for. And you'll get to see some people who are enjoying their passion or have enjoyed. This gentleman here, we tease him that if he could, he would get a steam-powered cell phone, all right? But one of the cool things they have here is they have a vacuum tube collection that would be worthy of the Smithsonian. So there's people with awesome talents, not just in VCF, right? Oh, and one thing that's cool is 90 years to the day, we had our first busload of students come here. And that's pretty fun. And as a corporation, we've been around for 26 years, and this whole process started in 1993. So what we're trying to do, inspire people and honor people. Okay? Here's the challenge. Many people, Dr. Fryman, for example, and others became scientists or engineers because they could change vacuum tubes and become the family hero, right? They would take a tube out that didn't look to be glowing, go down to the Newberry's to a tube tester, get a replacement tube, and come home, and Grandma and Grandpa showered them with praise, okay? So there's those nasty little stickers. There's not one on my cell phone, but it basically says no user serviceable components. And given that I get to wear this hat, and people come up and go, oh, did you go to Princeton? And trying to be a wise guy, I'll say, no, they pay me to go to Princeton. So you always have to have an Albert Einstein quote. And he's still the man. A friend of mine said the 20th century was invented in New Jersey, and of course, the bomb ended the war, but radar won it, and inside the bomb were 4 radar redundant triggers to set the bomb off at the right height, and those triggers came from here. Lots of secret stuff, okay? History. This is the short course, and you'll note one is highlighted. They had the first transistor laboratory outside of Bell Labs on this facility, okay? What our goal is, and we're in the process of it, but the beautiful thing is when we were putting this together, we used the resources of the American Association of Science and Technology Centers, and they cautioned that many a new center started with too small of a space and then they filled the space up, and then they stalled, okay? We have 50,000 untapped space here, and so we feel the future is bright, and seeing the strength of this organization, that's power for the future, okay? So you're one of the groups that contribute, and we have memorials to people. You see some of them around here, to Marconi, Edwin Armstrong, and many more. And we have an archive and a library, and it's fun to say historians on their way to their PhD have tapped our resources, okay? The benefits, motivation, education for kids. When we were putting this together, I didn't think one of our audience would be the volunteers, okay? The people who love their organization, love their passion, and come here and practice it, okay? One of the meaningful days along the way here is we had a World War II veteran who had fought on Iwo Jima, and like all veterans of World War II, they timed out. And we went to his wake, and his family came up to us and said, Dad lived longer and was happier the last 6 years of his life because he could go to the museum and talk to kids. What a meaningful payback. And then, of course, we save stuff. All right? Now, a little bit of the history, because we can't get to transistors without the history, and some of the knowledge that was built here turbocharged the difference from an amazing breakthrough to something that you could enjoy in your device. It was a Marconi station. The main building out front that you signed in, that's the Marconi Hotel. It took that building full of technicians to run a 24/7 international wireless system. Okay? And there's the map there. Okay? There's some of the buildings. This is a cool collection at the Smithsonian, the Clark Collection, and it started right in the building where you signed in. And it's, I forget how many folders at the Smithsonian, but for a person who likes Camp Evans pearls, it's a candy land. Okay. Now, we're skipping World War I and some other intervening things. And now we're at World War II, and it's expanded. The Marconi 400-foot antennas are gone. They bought up farmland in the back. They put up a parking lot, which if you stayed up late looking at these photos, you'd see there's a laboratory to train people on how to deploy radar stations all over the globe. And that's one of those things that when the Army did its History of World War II for the technical series was mentioned as an important thing. All righty. They also got the other guy's stuff. We still get the other guy's stuff. That's part of the game of war, right? There's a German radar called the Würzburger, a V2, and then a Würzburg Riese is the grayed out one in the bottom. Okay. All right. We also, using cutting edge vacuum tubes, we had tubes on the cover of electronics. Ooh, right? And that tube went into that radar up in the top photo. And those radars were landed on D-Day and many of the Pacific Islands, because in 20 minutes you could set up and tune and get 50 miles coverages, which at the rate of flight of those planes gave you over a half hour of warning to either get your guns ready or to take cover. So there we go. And that's called the Zoll tube, and we'll touch on that a little more later. Not a transistor. Okay. Look at how big it is. Look at how much work it takes to prepare it. You need an expert glass blower. And then when you ship it, you have to have specialized packaging. Lots of problems, okay? Here's another device, because this was part of the growth of the military-industrial complex. So look at who's involved. MIT and lots of corporations that I won't name them all. And this particular device served in Anzio and on D-Day, and it helped shoot down the buzz bombs. And we shared it with the Soviet Army because back then, the enemy of my enemy is my friend. So they used it to good effect to shoot down Luftwaffe planes just as we did. We would come to regret that sharing of technology a little later, but that's another story. D-Day preparations. We spoofed them. We fed them all sorts of false information that the real landing was going to be at Calais. And the ships that they would see coming at Normandy was a fake. And having captured their radar, technicians developed a way to spoof those radars that you saw a couple slides ago. And as the force was approaching Normandy and attacking, their radar scope showed a larger flotilla of ships and planes heading towards Calais. And it was all a radar mirage, okay? And that's part of what held up them from attacking over 24 hours before marshaling their troops and going after Normandy. But by then, there was enough men and material on the beach to resist those counterattacks. And in this lower picture here, did any of you notice that airplane in the field? That's the field. That's them testing a device, a beacon that was dropped with the Normandy Pathfinders. These were the crazy nut volunteers in the 101st Airborne band of brother kind of guys who dropped with a parachute with that thing. We have oral history stories of having that device in its development stages dropped from one ladder to a taller ladder and reworked so that when you jumped out of a plane and you hit the ground and the cushion bag hit the ground, it would still work, right? Okay, so the war is coming to an end and they realized that radar was a major reason for victory, okay? And tubes helped win World War II, right? And there's our World War II hero that nobody recognizes except for technology people is Tubey, right? Now, along the war, they had a unit that started up from the ground because they didn't need this technology. In World War I, it's another slide, they only had 6 tubes to worry about because air to ground and other communications through electronic means was very primitive, but it was started. So they had a special group under this gentleman's leadership that was the Joint Army-Navy. Notice they worked together, their vacuum tube section or thermionic sections. And here's their org chart, here's the people. There's one of the lab buildings. If you go into the Military Technology Museum, the first section you walk into, that's one of the labs that was there. And this is a little grab from a post-war newspaper story about how tubes show the way to victory. Okay, pretty cool. And this one, a little personal story. These were the initial badges when the laboratory moved from Fort Monmouth, because there were German spies in Fort Monmouth, and then moved to Sandy Hook, where they can completely control access. And then they said, oh, U-boats could surface and pick us off left and right, because Sandy Hook, there's channels so close, you could throw rocks at U-boats, right? And so they looked for a place, and they found here. So here's one of the initial badges. This gentleman was in England when they realized, or the command here realized, if you call it the radar laboratory, possibly the Germans would figure out that's where you're doing radar research. So they said, change the name, and that's how it became Camp Evans. So through the IEEE connection, this gentleman, Eugene Anderson, contacted us, and I do my best job. If you say your grandma worked at Camp Evans or your aunt, I will do my best to shake you down for any pictures you have, all right? So he was not spared, and he comes back and he says, you know, I took a vow, and I'm sort of funny about it, but I said I will not release any of this information without the authorization of my superiors, who are all dead, or in my lifetime. So, you know, I sort of gently pleaded, like, come on, it's all declassified. People give us stuff all the time. You don't have to worry. You know, they're not going to pull the Espionage Act on you. So, but he wouldn't budge. And a couple of years later, I get a call, and it's from his wife, who also worked at Camp Evans. And she goes, I regret to inform you, Eugene has passed away, but he left me instructions. And he said, you'd understand, there's a UPS package on its way to you. Here's the reference number. Eugene has filled his secrecy vow. Okay, and that's how I got a lot of information about the tube lab, which they were building up a level of expertise on how to handle electronic components that would dovetail with the invention of the transistor, because American troops had to fight everywhere, jungles, deserts, the Arctic, and the conditions were different all the time. In a steamy jungle with lots of moisture where fungus would grow on the wires, and they actually had early equipment short out because whatever material they coated on the wires got compromised by fungus and shorted out where they touched, okay? Who would have thought that, okay? And when you're jumping off a landing craft and you're carrying your radio or your beacon or your whatever, or your portable radar, there's a lot of saltwater mist around to compromise your equipment, all right? Not to mention it has to fly and jump out of airplanes with certain people. So they went from 6 tubes in World War I to over 1,200 approved tubes in World War II, of which 244 were preferred, because you had to have equipment that you could switch around. If a unit got destroyed, got hit, got whatever, it could become a parts goat, okay? Because you needed parts, and Amazon was not there, and they didn't deliver to Iwo Jima or Guadalcanal. So, all right. This group had to approve the types because they were up against RCA and other company salesmen who insisted that their tubes were the best and you could only use their tubes, right? So I'm sure it was a constant battle, right? They had to deal with these manufacturers. You had to come up with specifications and documentations because and you had to come up with documentation because if you were getting shelled in an area and you had to rebuild a set or something, cartoons became, or diagrams became much more meaningful than a lot of text, okay? All right, you had to have absolute interchangeability. I would like to be able to switch my battery from this laptop to another manufacturer's laptop when this one died, you know, and in that case it would be vacuum tubes, okay? Life tests. We have pictures from the National Archives of dozens of radar units being set up in a field in the back and just run for days and days and days to see what would wear out, short out, etc. Because, you know, you didn't have repairmen coming to the field that quickly when people were shooting at you. Okay. All right, shock and vibration, we touched on that, okay? In laboratories here, they had shaker tables where they would sit new devices on and shake them for hours to see what would fail. And they also had cold rooms and steam rooms where they would take the units and bake them and steam them and see what went wrong and fix it, right? Humidity, salt spray, and plus then you had to make calibration equipment. So, you know, when you were in Europe on D-Day +3 and things need to be retuned, refixed, or repaired, you had the equipment to get it at the right frequency or whatever. Okay. All right, so here's a newspaper, the Daily News, my favorite because it has pictures, okay? That also, same thing was on the New York Times front page above the fold. And I don't know the equivalent of that. Maybe it's being on the front page of Google that day. But here we go. Radar equipment from Camp Evans, New Jersey. The heroes of naval radar. The history never ends. These gentlemen were here during World War I, and they put a team together that when they were reconstituted by the Navy for naval research, thanks to Thomas Edison, they became the heart of the Naval Research Laboratory, and they invented radar for the Navy. The Army invented their own radar, and then here's a great quote from President Truman, and I highlighted the yellow part, and we have now won the battles of the laboratories. And the military-industrial complex was born, and the military understood that they couldn't do it without industry. Now, all right, so they have this mature industry of vacuum tubes. Why do you want to replace it? Okay. Look at the estimate of the price, what a transistor would cost once they got developed. So there was really low to no motivation, okay? But look at the things that you would get. Better reliability, increased longevity, longer cost, smaller size, reduced heating. This bench is the size of many radio consoles in your home. Did you care how much it weighed? No. Did you care, let's see, how much power it took? No, right? Do you care if it gives off heat? No, because it went in your room, okay? So, no motivation. Okay. All right. The Army had motivation because they first had the walkie-talkie, and then they started a miniaturization program without the transistor, and they came up with the handy-talkie, right? And again, you had to jump off a landing craft with these things, okay? Now, the batteries at the time would last for 24 to 36 hours because they were just carbon batteries. And they had a section here to come up with new batteries, and later on they would start the basics for lithium batteries, but that's in the future from World War II. But it's documented that it took 8 billion batteries to win World War II. So the Army felt the need to have lower draw electronics, and those that weighed less and was less susceptible to shock and vibration problems. Okay. Now, part of the thing was to make things smaller, faster, better. Right? So there was a motivation. One of the motivated people was Bell Labs, and their goal was to replace the relays in the switching system that they had around the nation, right? The Army was seeing the future, and they also had to solve a problem. Miniaturization wasn't the initial goal. It was putting things together. Sadly, us guys, we were not desirable as help in factories except for being managers because we just messed up too much. Okay, when it said solder A to A prime on a diagram, after so many hours we'd put A to B prime or whatever. So there was a lot of time spent on reworking things and finding the problems. So the ladies were way better at this. Okay? And then you had the Rosie the Riveter effect because a lot of men were in the front, but there were still enough men around to fill the factories. It just, we couldn't perform as well. So the Army came up with a process that we now call, flow soldering, and they called it auto assembly because you automatically assembled it, and once you got things standardized with the same number of legs in the same position, you could just pop them through a board on a template, flow solder across, and you were done. The reworking was virtually eliminated. Okay, so here's the breakthrough, right? And it was done by AT&T on a pure research thing, because that was the beauty of that national treasure, was that they had spare cash to go have fun, all right? And so here's the initial device that we've all seen. There's the stars, or the heroes of this, who later got the Nobel Prize. And how do you get from this to a stamp, right? We'll talk about that because the transistor was fragile, cumbersome, and it wasn't ready for prime time. Okay. So because Bell Labs had so many contracts during the war, they understood that the military was a good source of funds, and you didn't want to upset your big funder, right? That was the hand that fed a lot of Bell Labs. And so they had a secret disclosure to the military prior to the public disclosure. And one of the invitees was Harold Zoll, the chief scientist of this laboratory, with the Zoll tube named after him. This is his memoirs in a book called Electrons Away. This is a book that I have one of the later volumes here, and it's called Crystal Fire, and it tells a story about this, as well as when a lot of this documentation about the making of the transistor into a product, it was in this collection of books in a chapter by Mr. Harold Misa, right? So the Signal Corps was paying, this laboratory was doing work in its vacuum tube lab to come up with a device that exploited the semiconductor effect. And they were also paying universities around the country, most notably Purdue. And Purdue was putting out unclassified papers, and they were available to any researcher. So when they did get the breakthrough, there's a possibility that some of the Bell Lab researchers read the papers and maybe benefited from them, but that's pure conjecture on my part, because if you can't tell, I'm very biased towards Camp Evans, And so at the end of the demonstration, Shockley came over to Harold Zoll and buttonholed him and said, you hadn't actually developed this already and classified it secret? And Zoll had to admit, nah, they had not. And he goes, I felt my Nobel Prize fly out the window, right? Because he knew it was that fundamental of invention. And then a few years ago, a gentleman who claimed to have worked in the vacuum tube section during this period came, and this was his story, which I haven't validated, but he claimed that once it was discovered at Bell Labs and they got more information on how it was done, they went back and looked, how did they miss it, like a failure analysis. And his story was the doorknobs, and you can see them over by the VCF museum, are metal. And he claimed that they found out that just the metal that you would get on your hands, that would get on your glassware, that would get into your to make germanium or silicon to try and get this effect, that was ruining the doping because they didn't really understand the level of doping that they needed. And he said that the Bell Labs facility in Murray Hill had porcelain doorknobs. Does sound like a good story? I haven't gone to, I got to go to Murray Hill way before involved in Camp Evans and sit on a cray, but I didn't think to look at the doorknobs at that time. So it's a fun story. But anyway, here's Zal's contribution to this process that is key. The Pentagon said, let's have another Manhattan Project. So that way we'll get so far ahead of the Soviets, they'll never catch up, right? And he advocated for, no, if we try to hide it, they'll smell it. And they'll jump right on it because if it's that significant to us, they'll copy. So he said, just announce it. Just announce it like any other scientific thing. And they did. They did a public announcement. Here's a picture I picked off the book here. And they had good attendance. But afterwards, in the press follow-up, it was like, ho-hum. We got vacuum tubes. The vacuum tube's the king. This costs too much money. Yep, move on. Okay? All right? So from its announcement to the early 1950s, there was little investment in making that breakthrough into a product. But Zal was building momentum, and he started to win the funding to send over to Bell Labs and others to get this into a product that they could use because they needed it, all right? And so here we go, because the Tubi was king, right? For financial reasons and for process reasons, there were companies cranking out vacuum tubes left and right. There were expertise to the nth level. It was like the days in the railroad of they're still building steam engines and there's diesels coming out. They had to learn how to use diesel engines, okay? So an industry is born. Harold Zal leads the Signal Corps to invest millions into transistors, okay? For the first 5 years of production life, the military bought over 50% of the transistors produced, and they didn't have army trucks pulling up to plants. They had RCA and other trucks, whether they were going to military assembly points or whatever. It just looked like day in and day out military production. So, and to make sure they had enough supply, they paid Western Electric to build a complete plant, okay? And then once they had the understanding of what you needed to run a good production line, look who else they gave a check to, right? Very much the story of the atomic bomb and the coronavirus. How did you get a vaccine? You took the risk, financial risk, away from your supplier. So in the Manhattan Project, they paid companies to just do it. The Apollo guidance computer, to get the rope memory that they used, they pay, I think it was Fairchild's, I forget. Just here's your check, do it. And I think if Frank was here, he'd tell you. And then they threw away the first production run and said, do it again, because now you know how to make them and you'll have a better life rate of them. Who has a checkbook like that? Oh, okay, I'd like a Mercedes. Crash it and say, give me a later production model because it'll be better, And then, of course, with the coronavirus, they went to the different companies like Genentech and said, how much do you need? Here's a check, get it done. No risk for the company. All right, so here's the plant in Reading, PA. having worked for Amdahl Corporation, I have a little collection of lucite tubes or cubes with parts in it, and so it seemed to have been a tradition in the electronics industry. I didn't have any full systems, though. They would take a lot of lucite. All right, here's the industry is starting to grow, and you notice at the black and white photo, and in the color photo, you have ladies. Back to ladies are much better, and auto assembly would start kicking in. And then with auto assembly, you also could harness miniaturization. And, oh geez, somebody has to help me here. What's the name of the law of prediction where every 18 months you're... Thank you, all right. Moore's law kicks in, and it keeps kicking, right? Right? And the icon of project or progress is the transistor radio, right? And here's the first one. And look at all those wonderful things. You could run it for weeks on one stinking little, I think it was a 9-volt battery, right? And, you know, it was great. And it just took 4 transistors and no vacuum tubes, right? And then our first transistorized computer was done courtesy of friends in the University of Manchester, right? And it just had 92 transistors, okay? One of the fun things about, you know, Camp Evans never quits. I had a PhD historian over at Fort Monmouth one day semi-scream at me, but it was advice in a pill that I would hear, right? And so I'm in his archives over at former Fort Monmouth, going through the little gray boxes and having happy days, and he comes out of his office, because he would just like, I'd walk in, he'd say hi, and I'd go to work. And he comes out and he goes, "Fred, stop it!" And I'm like, what? What? Just submit the application to get on the National Register. You will never stop finding Camp Evans history, and you're stuck. You just keep updating it and updating it. You're up to 37 pages of narrative. You could have made the case in 5. Submit the thing, and once you're on the National Register, nobody cares if it's 5 pages or 100. So I took his advice, and along the way, somebody pointed me, I think it might have been Evan, through an oral history at the Smithsonian, that Mr. Mauchly, who came up with the system ENIAC, you possibly have heard of it, was under contract to make calculations for radar coverage diagrams that he won from this laboratory. And it was thousands upon thousands of very simple calculations, but any things where there's hundreds or thousands of little things, even tribits in Star Wars or Star Trek, it's a lot of weight. So he realized he could use every calculator he could get his hands on at U of P, and he couldn't get the job done. So he put on paper something he had bouncing around in his head, the diagram for making this 18,000 vacuum tube giant calculator. And he went to his fellow professors and said, the Army's going to pay for my design to build it because they need this coverage, radar coverage diagrams, of which his fellow professor said, the Army's not going to pay for this. This is World War II. They need things that will get metal on top of the enemy. And so it was like, let's think of something your thing will do that they'll pay for. And what it came out was gun firing tables. Never being into the military, you know, you see guns on World at War, and you don't know that behind this gun is a Bell telephone, like White Pages book, with all the different adjustments you need to make depending on the humidity, the wind direction, the temperature, because they would take brand new guns out of the factory that were made the same day out of the same pour of metal, and whatever reasons of crystal growth, when you would fire them in a firing range, the shells would not hit the same spot. So you had to make all these adjustments, and they went to the Army and said, we can produce these firing tables in minutes where it takes you weeks. And that's what the Army said, yes, here's your check, all right? They didn't deliver on time, but still, it was started, okay? And then, of course, the favorite is a Moby Dick, which is something that was produced through Sylvania for this laboratory, and we claim it's the first mobile computer, mobile because you could put it in a Mack truck. And the urban legend among the staff who talked to us said they needed a computer, and they went to their budget, and there was no money for computers. But there was a fat lump of money for mobile Army field equipment. So they bought a tractor trailer, they bought a system, they put the system in the tractor trailer, and theoretically, or as told to us, that as a mobile piece of Army field equipment, they had to take it off to an area to take it over bumps and whatever tilts and things like that. And the computer did fine. The truck failed because it was overweight, okay? All right. Okay, so this is sort of a summary, but then I'll go through a bunch of slides that give the motivation. But this is what the central role of the Signal Corps was through this laboratory and others. It was, they shaped the industry because you see Tubey there again, and because in making all those vacuum tubes and getting them out to the fronts, et cetera, and all the things they learned the hard way, because how do we learn? From the mistakes we make or the things that we can't anticipate until things get in the field, right? I kid around, rocket scientists. A lot of people say, oh, if that person's a rocket scientist. The conjecture is rocket scientists are not really smarter than anybody in this room. It's just they recognize that you need baby steps. And they didn't try to go to the moon on Apollo 1. They gave themselves 10 practice tries. And sadly, 3 guys didn't make it in the process, okay? But so brilliance can be masked with perseveration or taking biteable steps, okay? So you heard about how they guided the standards, they funded plants, they created production lines, they sponsored educational seminars. Here's a book that was written by some of the staff here and was published in, I think, a 6-part series in electronics, so motivated people of the day would read it. And so we went from vacuum tubes, thanks to the motivation of Harold Zoll, to early transistors, to something that our nation could be proud of and became a wonderful tool, okay? And why did they need it? Because the military understood the future, and this is very Camp Evans centric. Everything you see here is at Camp Evans. You know, the little signal there is when Harold Zoll and a team were trying to figure out what that Soviet globe was spinning around the planet called Sputnik. And if you worked so many uncompensated hours, you got a Royal Order of Sputnik Chaser Award. And if you go down to ISEC, you'll see one of the diplomas on display. They had a vacuum chamber in one of the buildings that's gone, where they would actually put early satellite designs with the early transistors, and they would learn material science like, you know, how we have cooling fins on some of the very hot chips, to take away the heat generated by the switching effect. you don't have cooling air in space. So you had that challenge to overcome. Some of the things that you used for insulation and substrates, they would sublimate in a vacuum. So lots to have been learned, okay? Weather science. The other day on April 1st, we celebrated another anniversary of the first weather satellite data being sent from this launch satellite called Tyros-1 to this dish, putting the data together into photographs. And that was the first weather satellite. They were gutsy persons because after so many launches had blown up on the pad, and you saw like one of our early Vanguard satellites bounce off the thing and then disappear in the flames, to launch a satellite on April Fool's Day, you were asking for it, okay? Why did they do it? Because they had confidence. And on April 1st in 1875, the first weather map was published in London, in the London Times. And if they could produce those auto-magic weather maps, they had eclipsed 85 years of technology history, and they did it, okay? And as you know, thanks to the transistor, you can get those weather maps on your phone nearly instantly. Okay, we had a nuclear research facility here run by one of the Operation Paperclip scientists who was never a Nazi, but once the Army has a program going, they sometimes piggyback other things on it. So if you came out of 1950s, 60s, a university, and you had done a very interesting PhD paper, you got invited to leave war-destroyed Europe and come work at an American military facility. Okay, so that was Dr. Cronenberg. Okay, out in the field, you see that plane. That plane could not do its guardrail mission of listening to cell phone transmissions and feeding them to satellites that gets to a center to be decoded. And a lot of that work was done here in the fields. You know, we wouldn't have that level of intelligence, and the grandchildren of that technology are flying around Israel and Ukraine today, okay? And it's called Guardrail, and thanks to you know, our very motivated volunteers, they raised the funds to buy one of those planes. And then the McNamara line and REMBAS, that was forest protection, okay? Other projects here, because notice it just gets bigger and bigger. Night vision that changed the nature of warfare. And then our newest acquisition is one of these firefinder radars, which if you shoot a shell that's equipped with firefinder, our forces can send, that's unclassified number, 32 thank yous to you in the forms of chunks of iron. They first deployed it in Iraq because the Soviets didn't come out to play. And when they would interview captured Iraqi soldiers, they said, we couldn't use our artillery because when we did, it rained steel. Okay, a very effective system. Lots of history, okay? We have an amazing success here. There's our first busload of kids. And it's due to dedicated people who have passion and made this happen. So there you go. Thank you very much. Any questions? Thanks.
Use that mic for answering. Question? Huh?
I have a quick housekeeping. Just a quick housekeeping task. If anyone is parked in the parking lot next to the softball field, Little League field, please move your car. They are going to tow it. That lot is marked for Little League only. Do not park there. If you don't know if it's you, I have a list of license plates, but they are not happy because they have a Little League game today. Okay? And that's all I have to say. And I think you meant it would be raining depleted uranium.
That's another story. Why would you send depleted uranium or a garden variety shell? They determined what kind of vehicle it was a tank or was it just a junky old troop transport in the fields over where they're now playing a Little League field. Okay, cool. It never quit, it never ends. And somebody had a question there. Oh, sorry, thanks. Go ahead.
Hello. So you said that that was brilliant news to learn that they sort of wanted to keep it quiet and uninteresting, and how tubes were winning. Where did this sort of Army investment influence the IBM Stretch project, which made the choice to go with transistors in what, 1955?
Well, I don't know it by the model, but 1953 to 56, 57 was like a growth year where the quality of the components were reassuring enough that a manufacturer would put them in. Okay. Now, I don't think they were ready for 5 nines reliability, like the industry would later come to demand, but that sounds about a right time that they would start to integrate transistors into their system. Okay. Thank you for the question.
So it wasn't the Army that sort of said to IBM, do this?
I don't know that, but the Army has often gone to manufacturers and said, here's a check, do this, okay? Right? I think that's it. Thank you very much.
Yes, everybody, give a warm hand for Fred Carl. Thank you.